Hi everyone, it's Jeff from Transient Specialists. Thanks for joining us today. Today we're going to be spending some time on the 3 most common mistakes we see when using a transient generator for IEC testing. This will hopefully save some time and the hassle of having to get a system repaired. This will generally apply to all test systems, however, we will have references to particular models throughout the video. Unlike some other types of immunity test equipment, transient generators and the associated coupling-decoupling networks can be fairly easily damaged. Each manufacturer has a slightly different design, and the steps in guidance in the documentation should be referenced when getting the test system set up. Let's go ahead now and let's get started with the first mistake we see. First, and oftentimes the most destructive mistakes we see with transient generators are using the direct output connection for powered on testing. This is a big issue. The direct output is used for a few different purposes: power off testing, connections to CDNs. However, all power on testing should be run through the coupling-decoupling network. For most transient generators on the market today, single-phase CDNs are built into the test system, as on the right side of the EM Test NX5 we're looking at right now. This might be where some confusion comes from, as some models have the direct out connection as well as the CDN connections on the front panel. Most manuals you see will explicitly state this and let you know that it will cause damage to the system regardless of the power level. If your equipment is powered on while it's connected to the direct output, it's probably already too late. The next issue we see is when transient generators and CDNs from different manufacturers are used together for AC power testing where line synchronization is required. IEC 61000-4-5 is a common immunity test and requires line synchronization when testing. We see this most often when surge testing is being conducted on 3-phase applications where external CDNs like the coupling NX7, which you can see below our NX5, are used. Line synchronization is the degree on the AC sine wave where the surge pulse is placed. This requires communication from the transient generator to the CDN to allow for the placement of the pulse at the corresponding degree which the user selects. This isn't an issue for electrical fast transients or for surge testing DC lines. We have also seen that attempting to make adjustments to allow for different manufacturers to operate together for line synchronization can cause damage to the transient generator or the other manufacturer's coupling-decoupling network. If you need compliance to IEC 61000-4-5 and are testing AC lines, best practice is to get them from the same manufacturer, like the EM test system we're looking at now. Another mistake we see is when auxiliary equipment electrically connected to the equipment under test is not connected through the coupling-decoupling network. This can cause lab circuit breakers to be tripped or unintended interference on the mains connection. Depending on the needs of the equipment under test, it can require multiple power or data connections for normal operation, which is typically how testing is conducted. This can lead to a situation where multiple connections will need to be run through the coupling-decoupling network. If they're not, surges can be transmitted from the equipment under test to the auxiliary equipment, then to our mains power. Incorrect connections with the CDNs or inputs, particularly those with complex or manual CDNs, can cause serious damage to the test equipment. We've seen this occur in a few different situations where inputs have been switched or other connections have been incorrect. This can send surges back to the generator or cause other issues that can permanently damage the system. There are also some less serious connection mistakes and We see this often with the Tessec NSG3060 in front of us now. There are two plugs for the inputs for the test system, and one's going to be on top with the NSG3060, and the bottom is going to be with our CDN 3061. And then we also have a gray input adapter for our equipment under test. It's important to be sure that both the system power inputs are connected in order for the system to be operational. Alright, that should complete the video today about the 3 common mistakes we come across with IEC transient generators. To help ensure testing goes smoothly and to avoid these, review the documentation and reach out to resources with questions before testing. We hope this video has been useful, and please keep us in mind if you ever need to rent IEC transient generators.